Serverless Machine Learning, 3 Paths to Success with AWS Machine Learning Hero, Cyril Bandolo. Cyril, wait, hold on. Oops, here we go. There we go. There we are. Hi, everybody.
Hi, Chris. Hi, everybody. How are you, Chris?
I am doing good, sir. Thank you for coming on. I appreciate you coming late in the day, your time. So we're doing a little bit of an unorthodox out of band vBrownBag. It's noon our time. Serverless machine learning, 3 paths to success. Before we get into it, if you are in the live studio audience, I encourage you to @vBrownBag us. We are paying attention on YouTube. Hey, Stephanie, how are you doing? Good to see you again. We are, like I said, we are live. So we've got Stephanie in the audience. We are on LinkedIn. We're on YouTube. We're on Bluesky now. And we're on Threads. So if you add us in any of those places, you will find us and you can ask me questions. And I will pass them on to our esteemed presenter today, Machine Learning Hero Cyril. What's going on in Cameroon? How you been?
Yo, yeah, Chris, it's cool. It's cool. First thing is I'm happy we could find time, which I don't know, is it like suits both of us, even though I had to touch the vBrownBag time.
Oh, I don't mind at all. No, this is way worth it.
Oh, yeah. Thanks so much. So it's actually 6 p.m. here in Cameroon, and that should be 12 noon ET that way, right? Yeah,
perfect timing. So, exactly.
Yeah, so it's cool. It's quiet. The sun is down. We are winding down soon. Thinking of supper. Dinner is in my mind soon. So that's cool. Yeah.
Awesome. So you've been a machine learning hero for 2 years now, 2.5 years.
Yes, exactly. 2.5 years.
Congratulations. And you pinged me and said, hey, I want to talk about how to get into machine learning. And obviously that is a huge topic, machine learning, generative AI. But you've also got the additional flavor of serverless to add to this. So I think this is going to be a very relevant and very exciting talk for our listeners to hear today. Yeah.
It's really going to be, because coming from a machine learning or analytics background, there are certain ways of thinking or certain things we do by default that we feel that's where our strength is. Then there are serverless developers who mostly come from the web development's background. There are certain things they think, and they have their strengths in those areas. And now working in a serverless guru, a company which is doing serverless development work, and also as a machine learning hero, as the background from the analytics background, I had to come up with those knowledge gaps between these two, bring them together, and see how the two can have a heavy impact on. If you bring the two together, they all come with their strengths, and it could be very impactful in your career. It's a serverless machine learning developer,
Yeah, no, it's like I said, it's definitely top of mind. We've got reInvent next week, obviously. You'll have to excuse me. I still have a really bad cold from KubeCon last week. So I'm gonna be muting myself often to get a cough out or two. But yeah, in looking at the catalog for reInvent next week, hey, we have an AWS hero in the audience, Mike Fiedler. Hey, Mike, how are you doing?
Hey, Mike, how you doing?
Awesome. Yeah, I was looking at the catalog for reInvent next week, and it is jam-packed with GenAI, machine learning. Even my talk, it's a DevOps talk, but it's how to accelerate your DevOps journey using generative AI. So I am very excited to hear about this talk. So let me go ahead and throw up your presentation onto the stage, because I realize that as I'm asking you questions, you might already have them in the talk. So I'm going to shut up and let you do your thing.
Oh yeah, thanks so much, Chris. Sorry, I don't know if I should say sorry or I should be happy for the gift you got from KubeCon. You got a flu, you got a cold from KubeCon, but then you also met friends, and I'm sure you did some amazing things as usual. We've met in a couple of summits and conferences, and you're always very energetic and a very warm person to meet. So I'm sure Maybe you gave them your warmth and took a coal. Yeah,
I did. Yeah. I did. It wasn't a fair trade. I'm very upset.
Okay, sounds good. So I am AWS Machine Learning Hero. Cyril Bandolo is my name. I'm on Twitter, LinkedIn. I'm also considering joining Bluesky. So yeah, I'll probably add my handle for Bluesky later, So
Love to see it.
I actually come from an analysis background. So like from Excel, SQL, Power BI, and then now R. Back then, R was the winner. Before Python came, R was good for statistical analysis. Yeah, and then Python came with all the packages like PyTorch, TensorFlow from LinkedIn and Facebook. So Python took over R. So I had to go to Python. So I have been from the analytics side of things, and that has been my strength. So when I joined Serverless Guru, which is an AWS consulting partner. So I'm a developer in Serverless Guru. I was doing now lots of serverless work because I now was using my newly acquired cloud skills and working in the room. Most of my colleagues are full stack developers. So they have other tech stacks, which we'll also talk about here. And I realized that, okay, we need to bring serverless and machine learning together. And that's why the talk is about serverless machine learning. And we are also going to look at the 3 parts to that, which in detail. So I'm also an AWS authorized instructor. That's also something about me. It's my passion to share. I wanted to share more on my YouTube channel. So I said, let me go learn how to teach, how to train, how to speak, how to communicate, especially pass on ideas. So I became AWS authorized instructor in Cameroon. So I'm the first ever in Cameroon to be an instructor. So it's also...
Oh, that's awesome. Congratulations.
Yeah. So lots of interesting things over the past 2.5 years, Chris. So if I move to the agenda, I know we need to address the elephant in the room. So what is really serverless from my perspective? I know Chris has heard about serverless every single time, but then we need to really say, okay, what's serverless again? What is machine learning again? And then what is the serverless machine learning in terms of what does it bring on the table to the developer or to the company? And then now the parts okay, I want to do serverless machine learning or build my applications using serverless machine learning architecture or way of working. Okay, how do I do that now? So we are going to look at the 3 parts. And then I'll also give you my advice, the little advice I can give to you. And if there is time, any Q&A, okay, we could trash that. So sounds good, Chris?
Sounds fantastic. I had to make sure I wasn't muted. I'm coughing too much. So yes, it sounds great.
Oh yeah, cool. Okay, so yeah, I'm sure you've seen this a couple of times. So when you're not using what we call serverless, you're like using an EC2 virtual machine. So your infrastructure services, you see that you do lots of work, the coding, the data, client-side encryption, OS configuration, network protection, server-side encryption. So you have lots of things you need to manage, lots of parameters you need to manage. And AWS just has the responsibility of providing you the hardware and maybe the compute and the storage. So you're doing lots of configuration on your own, and you need to lean on the expertise of your own developers to be able to create amazing applications for you. But when you talk about serverless now, you switch the responsibility. So you can see that most of the tasks is handled by AWS, the hardware, the compute storage, then the platform management, your server-side encryption, network protection, operating system configuration. The only thing that you are left with is just writing your code, your logic, how you want it to be, bringing your data, and then if you want to do some client-side encryption, yes, it's from the client side. So it's again not like there are no servers, but just the management, most of the configuration and the planning is done by AWS, and you just do the basic things which is around the code and data and your client-side encryption. So that's like kind of what serverless is. And when you talk about serverless, at the heart of serverless, you would always talk about AWS Lambda, which is a function as a service. So this is a fully managed service by AWS, which means it is serverless. So you just need to write some little code, and the rest of what it has to do will be managed by AWS for you. So it's also event-driven, which means if there is no activity, then there is nothing running, which is linked to the pay-as-you-go, because you only pay each time there is traffic or there is an activity or there is something going on. So each time it runs, and if there's no request or no event or no activity coming in, then Lambda doesn't run and you don't pay for that service, which can be attractive for maybe startups, companies that want to like do an MVP or do something quickly and then see how it works. So another interesting thing about AWS Lambda is that it integrates well with other AWS services. So if you've ever used Lambda before, I don't even know if there's any service in AWS if Lambda can't communicate with. So there's really integration with all the other services in AWS. And another interesting thing about Lambda is that it supports many languages. If you're comfortable with Python or Node.js or Go or whatever, Java, so you can always write your AWS Lambda code and benefit from all this we are talking about. So now, when I look at serverless developers, especially most of my colleagues in Serverless Guru, which again is where I'm working, and it's an AWS consulting partner. So most of the clients that we have, they come for serverless development tasks. Most of the serverless developers are web developers. So they come from the web development background, where they were more interested in, I want to build websites. And then the cloud came, and then they say, okay, now instead of building them locally, let me now build them in the cloud. So most of the time, they talk about TypeScript, Node.js. I've come across so many of my colleagues and so many people in the serverless domain that when I even talk to them about Python, they're like, no, I've never used that in my life. So it's like, it's Node.js, TypeScript. So that is the typical serverless developer, Node.js, TypeScript, and then infrastructure as code, so that it can help them to be able to build their infrastructure fast, because you need lots of infrastructure to put a website in place. So AWS Lambda is one of the major services that they use on AWS. DynamoDB for the NoSQL storage, API gateway and AppSync as the interface when you want to consult the get in touch or send a request to the application. So this is where their comfort zone is. That's this like their strength. But now, what's the weakness for the serverless developers I've come across? I've spoken with a couple of developers. I say, have you guys tried to look at machine learning? They say, no, calculus. I don't want maths. I don't want those. I don't want to do. There's too much math. There's too much calculus in this in machine learning. I don't want to go that road. Just let me be on my front end or my web development. So they don't want like math, statistics, linear algebra, things like that. And then also, every day we hear of new GenAI models coming up or machine learning models coming. I mean, it's just crazy. So they have limited machine learning algorithm knowledge, even to understand what is going on under the hood. So everything just looks like magic. I mean, it's just so surprising. So they've not really taken the time to go close to it to understand maybe the concepts like gradient descent, backward propagation, forward propagation in neural networks. So there are some things that, okay, maybe if you take the time to just understand one or two of them, you'll be able to extend that to all the new models that are coming out. But because they haven't looked at that, they are just shunning it. And then again, no Python for data science. So we all say, okay, let's go learn Python now. We're going to do core Python. Then we are going to learn classes, and then we start moving. Somebody as a serverless developer is going to move to Django, Flask, start learning how to build websites. Those are the packages that the person will be more interested in, while data scientists will be moving towards things like Pandas, NumPy, scikit-learn, Seaborn, Matplotlib. So we are like diverging. We go different separate routes. So there is no link between the Django and maybe the Pandas, for example. So they are not really comfortable with that. I remember I spoke with one of my colleagues, and he was so amazed by what Streamlit could do to put up a simple front end for your machine learning projects in Python. So he was really amazed about how simple and how interesting Streamlit could be. But, it's been somebody who's never used Python before, but has been on Node.js, TypeScript, Node.js. So it's a typical example of a serverless developer. So now let's talk about machine learning now. Let's talk about machine learning. So traditionally, when we are programming, we provide data, and then we provide rules to the computer, and the computer will provide us with answers. So we provide rules like, okay, if let's just say for a bank interest rate, if this person is having this bank balance, okay, this is the interest rate if he wants to loan money. Above from 50,000 to 10,000, okay, it's 10%. From 10,000 to 20,000 is 30%. From 20,000to 40, 50%. So it's more of like we are programming the rules ourselves, and then we are providing the data. So the machine now would be able to use the rules and the data and then give us answers. So the difficult or the key thing we are trying to do is provide the rules. But then what does machine learning bring on the table? It flips it a little bit. It says, okay, here are the data, here are the answers. Can you find me the pattern? Let's say this is my face. I want to be able to do a face detection. I want to know, okay, is this me or not? How do I program that? It's complicated. Okay, my eyes are round, So yeah, it's funny. So like Apple, you would say, okay, it's red, it's soft. Is it a tomato? It's round. It gets complicated. So you have to say if something is round and red and soft, and it gets complicated, right? So what machine learning tries to do is cut all of that and say, here's an apple, here is a tomato, here are berries. I'll give you 10,000 pictures of apples, 10,000 pictures of cats, kind of like that. And then you'll be able to know, okay, I get it. I get the rules myself. So in general, when I look at this is where these are the features I'm going to focus on. So again, it's just like the facial detection. It says, okay, I get it. I'm just going to focus on maybe the eyes and the lips and maybe the nose, and I'll be able to know more. I'm able to distinguish people by that. I'll forget about the face and the other parts. It's going to find its pattern. And then the interesting thing about machine learning is giving you those rules. So you now use the rules elsewhere. So you don't know the rules. You give data, you give answers. And then when it comes up with those rules, now you grab those rules, and everywhere you go now, you keep applying those rules. So that is what machine learning actually brings on the table. And we've heard of GenAI, so many things coming up, but all of this is part of AI, because AI is anything you're trying to, artificial intelligence is anything you're trying to make the machine to do that it could not do. You're trying to give it some intelligence, and you can either do it using machine learning, which uses data, statistics, or non-machine learning. Other parts of robotics and other aspects go under non-machine learning, which is still AI. But the difference with machine learning is that you need to use data and statistics to train the artificial machine to do something. And then inside machine learning now, you have the subset of machine learning, which is deep learning, which is using neural networks trying to simulate the human brain, inspired maybe by babies. Babies are born, first they start seeing shapes, colors, then they start associating it. So that's what deep learning is trying to do. We have so many neurons. The first layer might just determine just the outline, the shape, because sometimes I have a couple of friends that when I see them just walking, I can, from the back, I can know this is my friend walking without looking at his face. I say, okay, yeah, this is surely Chris, I'm sure I can be able to recognize you if you're moving the opposite direction, you know. So
all you have to do is look up. You know exactly what I. Oh, there's Chris.
Yeah, that's Chris. Yeah. So I would say the neurons now, each layer detects each layer. This one is responsible for the shapes, for the colors, for the texture, and then with all of that, it's going to say, okay, this is Chris. I know this is sure, definitely Chris. So the deep learning, and then there are other machine learning models that are not necessarily deep learning, like linear regression, other machine learning models that use other ways of looking at features and classifying or identifying certain things. Then now inside deep learning, we are now a step into deep learning where we are using GenAI, which GenAI is just using transformers, one of the deep learning models, and now it is trying to create a copy or something that should look like the original. It should look like, I want to create something that looks like an original version of something you've seen. So it's just creating copies that look authentic, that look real, that look realistic, that convince you that yes, this looks like something I've seen before. So that is just the subset. That's what GenAI is doing. And then there are other deep learning models, not necessarily only GenAI that we have. We have other models that are there, like convolutional neural networks, recurrent neural networks. So there are other things, other models that are not only GenAI. But for now, GenAI is taking a big portion. And like you said, the talks and reInvent, we are going to get a lot of GenAI. Yeah. So, and again, in GenAI, we can either be talking about recreating how we speak, the speaking, or the writing, which is the LLMs, the language, or what we see, the self-driving cars, what we see, the guns. So it could still be about it's not only LLMs that we have in the world now.
Right.
So the LLMs, which is more of the speech to text summarization, what we say or what we write or how we speak. Then the GANs, which is more of what we see, the video, so deep fake, things like that. So that is so we know where we stand. And now, what is the core for a machine learning engineer is SageMaker. So this service is a machine learning Swiss knife on AWS. It can do so many things. It's also a managed service, which makes, it makes the life of a machine learning engineer a no stress life. And here in SageMaker, you can create models, you can train models, and you can deploy models, have multimodal endpoints, can do so many things with your models in SageMaker. It's really a very fantastic service on AWS when it comes to machine learning and maybe data scientists. So you have pre-trained models, you have built-in models, and you can even manage your instances, all that in SageMaker. Also, SageMaker integrates well with other services, and it's really a no stress for a machine learning engineer. Okay, so now as a machine learning engineer, most of the machine learning engineers come from analytics background, just like me, coming from the analytics side of things. Started with Excel. Then when the data became more than 1 million rows, I had to learn how to use SQL, which can take us to billions of rows of data. Then went to R, Power BI, all those, and Python. Started picking up those packages like Pandas, NumPy, Scikit-learn, PyTorch, TensorFlow. So each time something was coming up, Transformers, and now GenAI. So each time something was coming up, we keep picking it in that light from the analytics side of things. So now we have SageMaker as our core service, our Swiss knife, because SageMaker is really so fantastic. But now, what is the downside? Most of the time, we are avoiding HTML or CSS because we think it's like it's not analytical. It's like you're precising, designing, writing, so we tend to move away from that. Because
the opposite of what the web developers were doing.
Yes, exactly. Yes. So because actually they are the opposite ends. So it's like, oh no, I don't like HTML. I don't like CSS, maybe writing, defining the borders, defining how much spacing it should be, the size of the font, and if it's reflect, responsive or not. So I just don't want that. I want to be able to predict maybe what the company revenue would be, who are the customers who would churn. I find it exciting, improving revenue. So it's kind of that's the weakness. And then more now, we spend more time focused on accuracy, because it's been about how can I create a model that doesn't hallucinate, doesn't have any errors, it doesn't mislead anybody, it's no false positive, you like trying to make sure you create something very accurate. So you spend your time feature engineering, tuning your hyper parameter tuning, making sure that things are optimized for accuracy, and you don't get that big picture of infrastructure as code or the other CI/CD, the DevOps, all that whole package that the web developers or the DevOps do. So that's why you're less on the DevOps, because most of your time is on, I came out with a very accurate model. Fine. My model is smart. That's what I wanted to achieve, and I'm happy about it. Okay, but how can we give us an end-to-end application? So the software engineering principles are not that are not at the forefront, because again, the key was making sure that, okay, let the model be accurate and and less biased. So that software engineering principles are not really well respected. So now, what then now is serverless machine learning? So serverless machine learning, we've seen where that serverless, you focus on your code and the data you bring, and also your client-side encryption, as we saw when we started with serverless. But the additional thing about serverless machine learning is bringing in now your ML code into that serverless infrastructure, where yes, AWS still takes care of most of the work, operating system configuration, blah, 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 just like in the serverless, but now you're slotting in your ML code and benefiting from that less work that the serverless developer has to do. So the serverless machine learning now, developers would love it, because it helps them to have innovative and modern apps. The bar is high now. I don't think you could release an e-commerce application without having recommendations in it. Recommendations in it currently, in the modern age. Before you could, maybe. So now your application will just look bizarre if it doesn't have these new things, because the big companies, the big tech have already made it so the customers' expectations are so high. So any app you develop now, we just expect you to put some of these things inside. So also with serverless machine learning, we don't need all that math to get started. That's the good news. So those my friends who used to say, oh yeah, I don't want that calculus thing, I leave it to you guys, I'm just comfortable here. When you start looking at serverless machine learning, you don't need all that math to get started, which we're going to talk about in the parts. So you also now leverage the cloud service integrations, because now you're in the cloud and you can easily move from one service to the other, just the integrations that exist already between this service and that service and this one and that one. You just navigate, you just benefit from that, and which helps now with developer velocity and efficiency, because the developer is able to do more work now with less time and is happier, and is focusing on just the logic, mostly the business logic and the code, and then the rest of the serverless part of it is handled by the AWS. So now ML engineers now, who used to spend their time on accuracy, model accuracy, when they get to serverless machine learning now, they don't need to provision servers anymore like they would have been provisioning for their endpoints after creating their machine learning models. They have to manage infrastructure, manage scaling, manage all those things. Now they are just going to slot it in a serverless architecture and benefit from no server provision. So now you can have more app integration, because the serverless architecture, there's already maybe an ISC like serverless frameworks or SAM or CDK or whatever that is already running a whole full stack of a website. So you're just sliding in and you're benefiting from, okay, I just added my machine learning in here, and now customers can have this end-to-end app and see the beauty of what I'm doing. And then you have also the cost optimization, because serverless has always been about cost optimization, pay as you go. So for unpredictable demands, so for fluctuating demands is very good. So now the cost is reduced. So I don't need to have an always on EC2. I remember when I created my first machine learning model in SageMaker, I forgot to turn off the instance, right? Yeah, so credit card shock. Yeah, so I learned the hard way. So I mean, if there is no traffic, then you don't pay for that. And if there's traffic and you pay, you share the revenue with AWS. If your product is doing so well now, millions of people are hitting it. Oh, then that's good. Then go pay your taxes. So now more team collaboration, because we can now collaborate with the front end guys, especially in the microservice environment, the front end guys and the other developers. So I'm bringing my machine learning part of it and my innovation. Then you are bringing your front end React, and then we are all working together on application. So it also helps with the developer velocity for a machine learning engineer from the point of view, okay, now I can go faster. I can focus on just providing the machine learning code and not bothering about the server provision. So now, the 3 ways now to serverless machine learning. The first and the easiest is using the AI services. So AWS has a bunch of AI services that are just APIs. And if you have an existing application, let's say you have that old e-commerce application or an e-commerce application you just created as a serverless developer, the easiest thing you might want to do is to start with using AI services. Just use those APIs. You call those APIs, provide your data to them, and then they are going to give you a response. So it integrates easily with your application, and it also continuously learn with your data is going to be learning and improving in most cases, and it's only going to get better. So it's just serving you, it's just helping you provide you results quick without you having any machine learning experience. So you don't need any machine learning experience in this first part. It's the easiest, it's the seamless. So you have services like Amazon Recognition for face recognition, face detection. You can also have services like Amazon Transcribe for speech to text. You just call the API for Amazon Transcribe, provide the speech link, and then it's going to give you the text. You also have Amazon Comprehend for sentiment analysis and other interesting things you can do with your text. All you need to do is just an API call to these services. So this is really good for someone who has no machine learning experience and maybe is already having an application, and then you just want to add some intelligence or some translate to your website or things like that to improve it very, 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 very fast. And it can also be in the beginning, and then if later on now you want to have more customization, you want more flexibility, then you have SageMaker Serverless Inference, which was launched, I think, 2 years ago. SageMaker Serverless Inference. So think of it like a Lambda has been integrated directly into your SageMaker endpoint. So it makes it serverless. So, I mean, I wouldn't have been having that credit card shock if I use this, if I use this earlier, because it was just a personal app I was building. So there was no traffic when I logged out, but then I got billed. So now with this, if there's no traffic, then you don't get billed. So you benefit from that pay as you go. So there's no need for you to manage servers or manage how you're going to provision or manage how it's going to scale. It's going to scale automatically for you. You don't have to bother about that. And then it integrates easily with your MLOps pipeline. So if you're into MLOps, you can easily use this and it'll just be a part of your MLOps pipeline and have that end-to-end machine learning powered application that you've been wanting to build. And then also it you can easily host your models in the model registry. So this is for someone who wants to maybe customize some inbuilt models in SageMaker. So let's say, okay, you have some knowledge of machine learning, and you don't want to use the AI services, which were like just calling APIs and blindly not really knowing what is happening. So you can go to SageMaker, use some of the inbuilt machine learning models like linear learner. There are so many machine learning models, even XGBoost, things like that. You bring the container, you use the container, and then you like do your training, do some hyperparameter fine tuning, and then at the end now you come up with your endpoint and use it to serve your customers. So this is a bit of customization. Then now the third part, so it's good for fluctuating traffic. Forget the third part, it's good for fluctuating traffic. You're going to benefit from that. Like I said, I mean, if I was not using it, I don't pay. It can scale down to 0, and it's pay per use. You can also use provision concurrency just to make sure that things are warm. So now,
before you get into the third one, there's a comment from the audience that I just wanted to address real fast. So Mike Fiedler asked, "Is SageMaker serverless?" And so I responded, "Yes, SageMaker has a serverless option called SageMaker Inference." Serverless inference.
Yes.
And he said that's a subtle distinction. The only part of SageMaker that is serverless can be the inference runtime aspect, not the training development environment.
Yes, exactly. Yes. So that is because that is one of the complications, right, that we get when we want to use serverless for heavy machine learning work to train. Right. Yeah, because it's stateless, and
so you're not using you're not using serverless inference for the heavy training, like the big super large heavy lifting.
Inference, yes, for training, it's very tough. I think we are still trying to find.
And it would probably cost more than actually just renting a bunch of servers yourself anyway. So
it's complicated because there are times if you're doing pre-processing, you're doing feature engineering, and you need to remember the state. You need to remember where you were, and then the runtime. Let's say for some very heavy models, the runtime, for example, it's 15 minutes for a Lambda, but what you're running goes above 15 minutes, so it's going to forget what it was doing and start all over again. So you need to have those checkpoints. You need to have so many things when you are training, so it can really be very, very crazy to use that for training. It's really, it's really tough, Okay. So thanks, Mike, for that feedback, which also gave us some interesting things to say.
Don't give him any credit. It's just Mike. Don't say thank you to him.
Oh yeah. I shouldn't even thank Mike. He's doing his job, Mike's an AWS hero, a very nice, very kind AWS hero. So I shouldn't thank him, right? Yeah.
He's okay. He's kind of okay-ish.
Okay, so that's cool. So now for some people, they don't want to use the inbuilt machine learning models that we have in SageMaker, for example. Sometimes you even want to use an ensemble. You want to use maybe 2 or 3 models to vote. Let's say you have 5 models. So if 4 out of them vote that this picture is a cat, then it's actually a cat, So you bring them, you bunch, you ensemble them, you stack them together and they vote. So you've created your model. You have a good machine learning engineer in your team, and you don't want to use SageMaker inbuilt models, so you can bring your own container image. So that means now that you deploy your Lambda function as a container image, and you now containerize that model, put it in a Docker container, and store it, push it to ECR, Elastic Container Registry in AWS. So you store that your own container there with your own way of doing inference. And then now you can use that now to send responses to clients, to requests. So it's still linked to Mike's point. The problem with this is that you have a limit, 10 gigabyte memory. So you have things like TensorFlow. You have transformers. You have some models that have so many dependencies, are so heavy that they can't fit. They can never fit into this 10 gigabyte memory. But in case you have a light model, or you're trying to do some edge computing stuff, something really light, something really super light, then they could fit in this 10 GB memory. So again, you can use Python, Node.js, Java, whatever you want to, the runtime you want to use. You containerize it, push it to ECR, and the link, the inference link is what you'll be getting. So one of the key things about this is that you most likely be using the inference more in this case, because training is so complicated especially for large language models. Billions of parameters is so complicated. You must use some distributed computing, and can get really complicated. So this is for people who want to package. Let's say you need to package all your libraries and model weights, all have to fit in that 10 GB memory, which can be small, really. And then you can use like your pandas if you're comfortable with some pandas, scikit-learn, PyTorch. They can really fit there most of the time. And then easy to do your model versioning with your container tags. So you can always do that, know which model was very performant, and be able to do some A/B testing and things like that. So generally, this is for people who want to bring their own model. So you bring your own model to the cloud, and then you containerize it. So again, there are limits. And if your model is big, you can't go serverless ML. You just have to go to the virtual machine, right? Yeah, so my advice, first one is for you to really get the benefit of the serverless machine learning. It's good to think microservices, so that you're focusing on maybe creating that wonderful model which can scale in its own way and providing us the endpoint using your Python that you're comfortable with, and all the beautiful packages are found inside. Then others will take that, link it with the front end, deploy it as using a CI/CD pipeline, or infrastructure as code at the same time, some testing, some automated testing and things like that. But when you think microservices, it makes it easier for you, because you can easily focus on what you do best, say in terms of creating a model that can predict things in a certain way, and then the other as components are handled by other teammates. That's the first advice. And the second one, as Bernard said, you have to go build. You
gotta make something.
You gotta make something, you have to make something. So as Bernard said, you just have to make something. So Reinvent is around the corner, and I know there will be lots of interesting services, lots of things that will come out soon. So it's just to look at some of those that will come out and take advantage of them. One of the interesting things I've noticed is that it's always good. You can always start at any time. Maybe there's a new service that just made some tweaking that somebody has been doing throughout the year very easy. That's going to come out this December. So you would just come in now and start building with that new service. You would probably be running faster than somebody who's been trying to tweak maybe an EC2 to do what the Lambda is currently doing, So
right.
So it's just to go build, and it's always interesting to look at the new services that are coming up. Most of the time, they are less costly, they are more efficient. They have gotten some feedback from users, from community builders and heroes and all that. So go build. So, and I'll just shamelessly plug in my course here, because if you want to learn this, I have a full course, which is Serverless Machine Learning.
Wonderful.
Came out, it has all these in terms of taking you from the serverless to the machine learning to the serverless machine learning. It's a huge course, and I'm sure I'm going to go on with that course right till early next year, dropping it in sequence. So a serverless machine learning course. And these are some of the services we are going to actually build with, project-based. So awesome. The theory first, then we start building. So Lambda, DynamoDB, API Gateway, Event Bridge, so that microservice and that event-driven stuffs can work. And then we also are going to use SageMaker, serverless framework, infrastructure as code, SAM, Docker, Jest for testing, and also GitHub Actions for CI/CD. So it's really going to take you from zero again, because I come from both best of both worlds, from the other side, the analytics side and the machine learning side, and then the serverless, the full stack or whatever side. So I mean, yeah. So
this is sick, dude.
Yeah, some components.
I didn't even know you were making this. This is fantastic.
Yeah. So projects like this. So serverless e-commerce app without AI, how it's done for us, a normal serverless way of doing things before AI existed or without AI. There's also, now the serverless e-commerce app now with machine learning added. Okay, I have an old app. It's been sitting there for a couple of months now or years. Okay, I want to add some machine learning and revamp it. Yes, let's bring back that old app and add some machine learning to it. There's also, SageMaker app without serverless, how it was done, how it's done by machine learning engineers, how it used to be done, how it's done without serverless, how we would do it without serverless, just going straight into it. Okay, now let's take that same app now and do it now with serverless now. And then we're going to see how to do it with serverless. And also this serverless ML app using Docker and ECR. Okay, let's create this machine learning model we love so much, our way. This is what we want it to do. And now let's containerize it and push it to ECR. So there you can see the QR code is there for anybody who wants to take a look at it, join the course, and let's write. We're going to do there'll be lots of feedback. I'll be available for questions, answers, and then we modify.
I'm also going to put the links into the show notes as well, so that people will be able to click to it afterwards as well. I'm going to sign up myself.
Yeah, thanks so much. Thanks, Chris. Thanks so much. So a big thank you to you, Chris.
Yeah, of course. It's super. I'm a little bummed that we're not going to see you at reInvent next week, because we always have such a good time together, especially on the Monday night. So what I want to do is I'm going to put the link to the course in there, but I also want to get the link to your YouTube channel and your blog post too. So I'll get all of that information off of you offline, and I'll make sure that we add it into the show notes for the show so that people can click through and grab it all in one place. That'll be awesome.
Yeah, that'll be awesome, Chris. That'll be great. Yeah, I'm really going to miss you guys, but that's cool. I'll be there. I'll be online. I'll be following every single thing.
We'll be sending you messages in the Slack channel. Join the WhatsApp if you haven't already, and we'll send you pictures.
Yeah, but avoid FOMO. Yeah. Yeah, reduce the FOMO.
Good point.
Reduce the FOMO. Don't send too much beer. Just send pictures that are like simple pictures.
Oh man, awesome. Well, Cyril, thank you so much for coming on. I always love having you on the show. You're a wealth of knowledge, and I super appreciate you. Everybody, you can follow Cyril. He is Bandolo Cyril on Twitter right now, but he is, as soon as he gets off of here, he is going to get his Bluesky account, and then I will also be sharing that link in the show notes as well.
Yeah, thanks, Chris. Thanks so much. Yeah, thanks for having me. I'm really grateful. Yeah.
All right, everybody. Well, thanks very much for another week, and we will see you again next week. I will be at reInvent, but Damien is going to do an episode, so he will be running solo next week with another episode, and we'll see you then. Okay, bye.
Bye.